In this lesson, we're going to be talking about present value. So present value is defined as the principal that must be invested today to obtain a given amount in the future. So what I have here is the formula that we learned last week. So our final amount is equal to the principal times 1 plus I all to the power n. So I'm just going to take this formula and rearrange it for my p. So if I do this, I need to divide both sides by 1 plus I to the power of n. And so I'm going to be left with p is equal to a divided by 1 plus I to the power of n as the new formula that I'm going to be using today. So example 1 says, when Christian was born, his parents decided to invest some money so that he could have a gift of $20,000 on his 16th birthday. They decided on a compound interest government bond that paid 10% interest per year compounded monthly. After the initial amount was invested, there would be no further transactions until the bond reached maturity. How much money must be invested today to guarantee Christian's future amount of $20,000? So we're going to go ahead and we're going to talk about this solution. So just to summarize that, Christian's parents on the day of his birth said, we're going to put some money in the bank account right now. We're not going to touch it, but on his 16th birthday or in 16 years, we want to have $20,000. So what we know our final amount is $20,000. We know that we are trying to figure out the principal, how much we're investing today. We also know that the interest is 10%, so don't forget we need to divide that by 100 to put it into a decimal. But we also need to be dividing by that magic number. So I'm seeing right here that it's 10% interest compounded monthly. Monthly means our magic is 12. So 10 divided by 100 divided by 12 is 0.0083, and N is my number of years, which it says it's his 16th birthday. So 16 times that magic number. So 16 times 12. Now, if we think about this, it says that his interest is compounding every month for 16 years, which means this is where the 192 comes from. It's compounding 192 times. So I'm going to go ahead and I'm going to plug this into my formula, a over 1 plus I to the power of n. So 20,000 divided by 1 plus 0.0083 to the power of 192 is $4,090.67. So therefore, if his parents invest $4,090.67 today, they would have $20,000 in 16 years. All right, our last example. An investment earns 7.75% per annum compounded semi-annually. Determine the present value if the investment is worth $800 5 years from now. So I'm just going to go ahead and highlight a couple of things. So we have 7.75% compounded semi-annually. We are looking for the present value, and it's going to be worth $800 5 years from now. So I'm going to go ahead and just write this information out. So we know that our final amount is $800, and we know that we're looking for our present value. We also know that the interest rate is 7.75%, so don't forget to divide that by 100 to turn it into a decimal, and then divide by that magic number. So we see something semi-annually, that means our magic number is 2. Now when I do that, I'm going to get 0.03875. I also know that my n is 5 years, but again, we need to multiply by that magic number, so our n is 10. I'm going to go ahead and I'm going to plug that into my formula. P is equal to A over 1 plus I to the n. So P is equal to 800 divided by 1 plus 0.03875 to the power of 10. And on your calculator when you're doing this, a lot of you are going to have to solve the bottom or the denominator first, and then you can type the 800 divided by that number in. Either way, you should be getting $546.99. Now, the cool thing about these questions is that you're always going to be able to tell if your answer makes sense. So if you use the wrong formula, for example, if you thought they gave you P and you wanted to find A, you'd get an answer that didn't make sense. You'd get an answer over $800. This makes sense. If we invest $546.99 today, we will have $800 5 years from now.